All right. All right. So for tonight, we're going to finish off the systems of units with a quick look at the American units. Actually, I think I deleted them. Yep. I actually removed the review of American units from this one because, well, we're going to do more unit conversions. And if we can do unit conversions one way, we can do unit conversions another way. So same skill, no point in covering more vocab when you don't need it. We'll also cover time stuff. That's going to be first. It's going to be quick. Then we're going to look at geometry. That one should be a little bit more interesting. I have a lesson prepared on that, just covering rectangles, triangles, and circles. So just the basic stuff, area, perimeter, that sort of thing. Right. Okay, so reviewing system units of measurement. So again, a unit is something, there's a measurement, as any measurement, there's one of. So like a unit is an inch, a foot, a cup, a gallon, a meter, etc. So we have different sets of units for measurements like length, volume, mass, capacity, and obviously we measure time in minutes, seconds, hours, days, etc. When you group different units together, that's called a system. So we have the American units, we have the metric units, and yeah, that's pretty much it. So converting them was the tricky part, right? So unit conversions, what you end up doing is you take advantage of the rule that you can multiply anything by 1. So when we use multiplication to convert units, what we're actually doing is we're kind of multiplying by a complicated looking 1, because 60 seconds is 1 minute. So in that example down there, that's essentially multiplying by a complicated looking 1, right? So what you end up doing is we're going to multiply by as many of these conversion factors, they're called, in order to get from one type of unit to the other type of unit. See, where's this thing? There we go. So for instance, with this one, if you're converting minutes to seconds, for instance, you have 4 minutes, you put it over a 1. So you always put your initial units over a 1. That way, since everything's going to be in fraction form, it's just going to make things simpler to look at. And then we have to multiply by a conversion factor. So we're going from minutes to seconds, so our conversion factor is going to be dealing with how many minutes or how many seconds. So since we have minutes on top, we want to cancel that by having minutes on the bottom over here, because the canceling, just like factors, the units cancel the same way. So in this case, minutes would cancel with minutes, and the only unit you'd have left is seconds. You do your multiplication across on top and on bottom. In this case, it's 1 times 1 on the bottom, so you don't need to say it's over 1. So you end up with however many seconds it is we got. In this case, it's 240. But that's the general idea with all of these, is that you end up just multiplying by some conversion factor that will switch you from one unit to another unit. Here's another example. It took me a while to actually type this thing out, make an image, and spit it out, so I didn't make another one for the review. Same one as last time. So this one in particular says convert 7,920 yards into miles. So nice enough. The problem actually gives us a conversion factor. There are 1,760 yards in every mile. So we can write this out quite nicely as like a little conversion factor. So we set it up the same way as the last one, but we're trying to get from yards to miles. So since we have something that converts from yards to miles, we're going to set it up over here. Yards has to be on the bottom in order to cancel out from the top over here. And then miles go on top. You just put whatever numbers are next to that unit in the conversion factor. So 1 mile is 1,760 yards. And you do your multiplication. The yards would cancel out, so the only unit you'd have left is miles. You'd have this times 1 over 1 times that. So you end up with this thing. You can either break it down as a fraction or do division and get a decimal out of it. In this case, decimal works perfectly fine. It's 4.5 miles. And you call it good. Now, when it comes to units of time, this one kind of stands out from, the metric system or the American system because, we don't have metric time and American time. And if we did, I would hate everything. As it is, we have daylight savings and that complicates enough. So we have the usual units that we're all familiar with: seconds, minutes, hours, days. You can actually continue to build on that: weeks, months, years, decades, however much you need. Like if you needed to convert something into decades, you could very well say, oh, well, 1 decade is 10 years and convert whatever it is you're working with to years to get to that. For the most part, you usually use the smaller units when it comes to examples like this. Because, how often do you really need to know, say the last class of last fall? You might need to know the day at some point. You probably don't need to know how many days it's been since then. You might ballpark it by months, but you sure as heck wouldn't use a fraction of a decade, right? So, reasonable things. Let's do a couple of problems. Now these ones, I know I usually have problems for me, then problems for you for the time ones. I feel like we're pretty decent with those, that we can actually, convert them decently enough without having to do problems on their own. So I'm just going to run through these ones real quick. And you know what? I'm going to change that first one because honestly, that's too easy. There we go. Oh, but that covers the same concept as the last one. Let's make it weird. There we go.
Yes.
Yeah, why not? Let's see what fraction of a year 8 hours is. It's about a 1,000-ish. So we're gonna go 1 hour and 35 minutes into seconds. That way, if your kid's acting up, you know how high he needs to count to have about 1.5 hours of free time. Welcome to the party.
Hello, I'm just wondering if Edgar Badillo is here, but
I actually don't think he has attended a single class.
oh, really?
Yeah.
Because he's scheduled to take a post-test. So that's weird.
All right.
Okay, perfect. Thank you so much.
Well, now you know.
Okay.
That's kind of funny.
Maybe they have the wrong student.
No, there's oh, yeah, I guess he's not in this class, whatever. He was in my last class and he didn't show up, so I kind of just flipped the coin. Was he scheduled for this class at some point? No. Okay, whatever. I gave incorrect information. There have been actually a few people who never
Sure.
attended. Yeah, no, that's kind of awkward, but you know, whatever. At this point, I think it's only at like 2. Let me see. Now I'm just curious. And you know what? It's gonna drive me crazy if I don't correct myself. So I'm probably gonna run and be like, yo, actually, he's not in my class. Okay, there are in fact 3 students I've never. Oh, wait, no. Hey. Okay, the one student I was thinking of that I was about to say that he never showed up to class. He did in fact make it for 2 hours a month ago. So, all right. Cool. That's kind of awesome. I'm also here, but I'm going to be right back. You miss me?
Of course.
Yeah, right. All right, so we're doing convergent stuff. Where was I? Oh yeah, right there. I wrote stuff down. Mhm. Okay. So we are going to be doing unit conversions from 1 hour and 35 minutes into seconds. Now, the first thing that I would say, and the reason I changed it from saying minutes in the first place is because usually what you'd want to do is get all your units into the same type of unit. Having 1 hour and 35 minutes isn't very helpful, you know, because that's 2 quantities being added together. So what I would recommend is taking that hour and converting it to minutes. See, what I'm doing is I'm going to use the unit conversion thing. I am aware that I could just write down 60 minutes, but you know, I just wanted to show you guys how that would be set up. So you would be converting it to, let's see, 1 hour is 60 minutes. The hours would cancel. 1 times 60 is 60. I am concerned by the tickle in my throat, the warmth in my mouth, and the sneezing. This concerns me. especially considering my dad woke up with a cold today, so. It's the end of my vacation, man. I don't want to get sick and then go back to work. This is gonna suck. All right, so obviously this 1 hour is 60 minutes, but if this had been like, 4.2 hours and 35 minutes or something like that, you would use this exact setup and it would work. So that's the way I'm kind of rolling with things, is I like to say, okay, this is kind of a universal method of doing things. So we have that, and then we have that 35 minutes. So we have a total of 95 minutes that we need to convert. Okay, so 95 minutes. I'm gonna put it over 1, and we're gonna use our conversion rate from minutes to seconds. So minutes would have to be down here, so it would cancel.
Get around me. Bitch, I'm back in my ass got bigger. Pretty face in a real nice figure. Shoot your shot, nigga. Pull that trigger.
Yeah. Alright, sorry, you're getting muted. There we go. That was fun. So yes, 1 minute would be 60 seconds. And the minutes units would cancel. And then we would multiply straight across.
Multiply in this case.
Now, you might be able to look at this and say, well, this could have been easier. I could have just said, oh, this is 60. That would make it 95 minutes, and then I could have multiplied it by 60 right away to get the seconds. And yes, I can do that. And depending on the problem, I'm not gonna have a problem with it if you do that. The reason I did it this way is because this is a universal way of working this. If this problem is significantly harder, this method is still gonna apply. Just trying to get the method across, not so much the numbers. I don't much care what numbers these are. I just want the idea of the conversion to work.
So multiply 95.
95 times the 60, and that's over 1 times 1, which we don't need to put.
Let's say we have 5,700 seconds or what?
Yep. That's how long 1 hour and 35 minutes is. So if your kid makes you angry, just be like, okay, face the wall and count to 5,700 out loud. I'll be timing it. I'll know if you're cheating.
Oh, because it's seconds, I thought it was minutes. Okay, thank you.
Okay, so 8 hours into years. So obviously this is going to be kind of a fraction, right? So I'm going to put that over 1 as usual. And we're going to try to make our way up to years. Now, there's a couple of ways you could do this, kind of informal. Personally, I think it'd be easiest to get hours to days, because we know how many hours are in a day, and then get days to years because we know how many days are in a year, right? So that's my plan. I'm going to go from hours to days to years. You ever have to like think about it and map it out? There's nothing wrong with just writing down your plan. That way you can kind of keep track of where you are. Oh my God. I'm getting sick, aren't I? I'm gonna
Don't
be
get
angry.
sick, don't get sick
I don't want to get sick.
until these 2 weeks finish the classes.
I know, right? I'm less worried about the grand total of 10 hours of teaching this class because I know I can pull that off. I'm more worried about the multiple 8-hour shifts I have to pull at 7 in the morning for the rest of the week. So. I'm not gonna lie, this is probably gonna be a short class. It's getting worse very quickly. All right, moving on. So. We're going from hours to days. So hours is gonna have to be down here. Days would be up here. So 1 day is 24 hours, right? So the hours would cancel. And if we multiplied across right now, we would be in days, right? But we're not done yet because we want to go from days to years. So one year is 365 days, right? So the days would cancel. And now we have, well, something, right? Our units, the only units that aren't crossed out are years. So that means that whatever this thing is, when multiplied across, is going to be in years. So let's multiply across on top. 8 times 1 times 1 is 8 over 1 times 24 times 365. I can't do that off the top of my head, believe it or not. And that's 8 over 8,760. So, tiny number. Depending on how you might do this, you might simplify this as a fraction. I don't think that goes in. It does go in evenly. If I was to simplify this as a fraction, 8 would go into this 1,095 times. So about, like I said, about 1,000. But there's also nothing wrong with if you punch this into your calculator. It is going to give you, I should put my units on here. It is going to give you about 0.000913. And we're starting to tread into the point where you would actually use scientific notation. And that would still be in years. So that is the decimal that 8 hours is out of a year. Tiny little guy. Yeah. Now this one was saying if you work 5 days a week for 4 hours a day, how many minutes do you work per week? Okay. So I have an interesting way of doing this because we know that to figure out how many hours you work in a week, we would end up multiplying these, right? If you work 5 days a week and you work 4 hours a day, you'd multiply. Well, interestingly enough, we can show this the exact same way that we've been doing this. So if I do it this way, what units do I have left? Hours over weeks. All right, that's how many hours I will work in 1 week. You'd multiply across, we'd get 20, whoop-de-doo, right? But now we need to convert this thing to minutes. So instead of just multiplying these and figuring out how many hours we work and then converting that to minutes per week, why don't we just use a conversion factor and go from hours to minutes? 1 hour is 60 minutes. The hours would cancel. And what units do we have right now? Well,
hours and minutes.
minutes and week. So right now we're in minutes per week. That's what it was asking for. It was asking for what, how many minutes do you work per week? And how many seconds is it that you work per week? Well, if I multiply straight across right now, I have 5 times 4, which is 20, times 60. It's 1200. And the units are minutes. And if this was more complicated on the bottom, I would multiply across and then put week next to it. But since this is all 1, 1, 1, 1, 1, you know, this would be out of 1 week. So you could say minutes per week. And whoop-de-doo, we're good there. Now we wanted to answer how many seconds do we work per week? One minute is 60 seconds. We are now in seconds per week. 60 times 1200, well, 6 times 12 is 72, and there's 1, 2, 3 zeros between these guys. And that's going to be in seconds per week, because that week, 1 week is still what's on the bottom. So 72,000 seconds in a week. So that's only 4 hours a day. So if you just hate your job and you're staring at the clock and over 5 days, you manage to count to 72,000. If it's a full-time job, you're only halfway there. Isn't that messed up? It's horrible to think of like that.
70,000 seconds per week,
Yep,
just in 4 hours.
in 4 hours. So if you wanted to know how many hours or how many seconds you work in a week for an 8-hour shift, on the off chance that you work exactly 8 hours every day, you would double that. So it'd be 144,000 seconds in a week. Right? It's horrible to think about.
They work 10 hours every day,
Ooh,
Monday to Saturday.
a nice thing about computing that one is 10's an easy number to multiply. All right. I assume we're having fun with these. Let's do more stuff. Let's look at the metric system. So these next several slides have a ton of information on them, none of which you're going to need to memorize, and much of which you will not use. I actually made a slide using all of these different types of units, but really I've never really messed with a lot of them. So the metric system is actually kind of interesting. Everything is based around tens. And it kind of starts off, I used meter as an example in this one, but smaller units than one of your standard unit have Latin prefixes. So deci means 10, centi means 100, milli means 1,000. And, you know, we've heard centimeter, millimeter. You ever heard decimeter? Nah, that's not something that's hanging out on a random ruler. So that one we tend to not use too much. And these are all fractional ones. On the right, units larger have Greek prefixes. Deca is 10, hecta means 100, and kilo means 1,000. Now, you might have heard of meters, you might have heard of kilometers. You ever hear of decameters, hectometers? Not really, right? So these are certain units. There are certain units that you just don't run across. So I actually have a slide for all of our different types of units. But the interesting thing with the metric system is they're all pretty much identical. Right? This is why I like metric more than American, because I have to remember 10 instead of, 16, 2, 4, whatever.
Do you know what do I see at the test? I saw like a triangle. And they say this side has this side has this side. And now answer what's the side of this triangle.
What's the other side?
Yeah,
Oh, don't worry.
and I was thinking, oh, hopefully next class I will see that because.
There it is right there.
Okay.
We have to get to 25 slides to get to there though, but we're already at 8. So
All right.
I don't know if we're gonna get quite that far, but yeah, it's pretty easy actually. Even actually finished my Pythagorean theorem stuff. I did. I wrote all of this morning. I actually used, it's interesting, actually, once we get into the geometry stuff, I actually used the Chat GPT AI to help me write like the whole thing. I would give it parameters and how long I want something to be, and it would spit something out, and I'd rewrite it a little bit to, make it a little bit more easy to stomach around here. And I used it for problems and everything, but after slide, starting with slide 14 through 37, I typed all that out in like 2 hours, and getting that thing to write things in terms of how I want it to be is not always the easiest, but it worked. So gonna make use of that. So yeah, length. For the most part with the metric system, we really are only gonna stress what the units are. So in this case, length is gonna be dealing with meters. And some of these units you will have seen. Kilometer we use, but when was the last time you saw a hectometer and a decameter? Never, right? Over here with small units, centimeter and millimeter. Oops. We've used these, but decimeter, haven't used that, right? So that we don't really use. And actually, it's pretty much the same for most of these. Actually, I think all of them, where we only really use half of these particular units. So that makes life a little bit easier, but like I said before, it's less about memorizing what the units are and more about being able to work with them. Because again, we are going to have, these unit conversions on here. There's meters, centimeters, kilometers. In capacity, guess which ones you tend to use for the metric system? Literally just liters and milliliters. You don't really use a whole lot else. And then weight is in grams, kilograms, milligrams. You don't use a whole lot past that. Certain medications, you'll see units like micrograms, and those are much, much smaller. I forget how many zeros that has. I think like 7 or 8. But stuff like pharmaceuticals would, 1, make use of scientific notation, and 2, have very, very tiny things. Almost like a stabbing pain in my throat. That's cool. You're just watching me fall apart. It's just happening right now. I don't have a very good immune system, so when I get sick, it's like I get hit in the face with a brick.
Oh, no.
I fall apart very, very quickly. I look like I've had a flu for 3 months.
Really?
Yeah,
So long?
no, it just hits you. Um. So those are the length ones. Mass, like I just covered or just mentioned, really you usually just use grams, milligrams, and kilograms. Because you have like centigrams, decigrams, decagrams, hectograms. Those ones you really don't use, or at the very least, I've never used them. Now, one thing I did want to cover on mass is that it's comparable to the American system of units of weight, right? But with weight, we might have heard, oh yeah, well, if you're on the moon, you weigh about 1/6 as much as you do on Earth, right? Well, mass is different. Mass is a measurement of the amount of matter in an object. So your mass would be the same between here and the moon. The units in the American system for weight deal with gravity, awkwardly enough. They're 100% dependent on our gravity. But other than that, mass is like a whole different scenario. Now, as long as you're assuming things on are happening on Earth, get over here, thank you. You can just convert between the two. There are conversions of going between the systems. But if you decided to do any calculations for like dealing with stuff on the International Space Station or how annoying things might be on the moon or how things are going to be for the first people to go to Mars and already know they're going to die there. That has been established. The first people we are sending to Mars have volunteered knowing that they are 100% not going to come back. They are going to die there. I would have volunteered too. Yeah. Hey, look, an entire planet without any people. Perfect. Yeah, but as long as Earth gravity is a thing, there are conversions between mass and weight. And again, for the most part, you only really use a couple of these. The main things to note are milligram, kilogram. Both of those are dealing with 1,000 of something and 1,000th of something. But the base unit of weight, should say mass. I don't know why it says weight. I think I copied over from the other side. The basic unit of mass is actually just the gram. Right. All right, that's cool.
That's why you pay attention to.
I'd say we gotta fix your phone, but yeah, if you're like driving home or something, do not pay attention to the Zoom meeting. Do not. Just don't. Just close it. If you're in the car, turn it off. Unless you're a passenger, then it's cool. Yeah. Not gonna lie, that's a new one. I have gotten a lot of weird things, so. Yeah, so other than that, we have capacity. And as I just mentioned, for the most part, you're really just using liters and milliliters. Probably going to cut down these slides in the future because, I mean, these units do exist. There is an HL, there is a DAL, which would make me very uncomfortable.
Where we can use this on this type of mission?
These particular units?
Yeah.
I don't know, it's Google decaliters, see where it pops up. Okay, there's a lot of definitions. There's a ton of definitions. No, no. Okay, so there is no such thing as a volume given in meters. I'm just gonna immediately disagree with this statement on allthescience.org. There is no such thing as a meter is a unit of length. We've already established that. It's not a unit of volume. They probably meant cubic meters. But yeah, cool. That's wrong. Yeah, so that's a unit that's just not really used. Probably same with hectoliters, deciliters, centiliters. Because really the thousand and the thousandths, those are the ones that are useful. Yeah. All right. Let's look at some examples. Let's look at some examples. And yes, of course, if you look at the side of this little screen here, it looks like there's more problems on the next slide. You know, I'm willing to bet you're gonna have to work those ones on your own. Just maybe. Yeah. So number one, Alice wants to convert her weight from kilograms to grams. She weighs 58 kilograms. How many grams does she weigh? All right, I'm just going to write down one at a time. So we're converting this thing to grams. So what we'd want to do is we're going to multiply by a conversion factor. We'd have kilograms down here and grams up here. So the question is, how many grams are in a kilogram or vice versa? Well, if we go back to, we don't even need to worry about which slide we're on for the metric system, because it's all about the prefixes, right? Kilo is 1,000. So every one of those kilograms is 1,000 grams, right? Just based on that, 1 kilogram, 1,000 grams, kilograms cancels, and our units are now in grams. So we do our multiplication, 58 times 1,000 is very nice. So 58,000 grams. We'll find that the multiplication in the metric system is so much easier because everything's tens. Okay, let's do another. This one's a little bit trickier. The density of water. I actually write that out. Density of water is 1 gram per milliliter. Convert to kilograms per liter. Well, that's an interesting one, right? So the way I'd set this up is whenever it says per something else, that's essentially division happening there. This is 1 gram for every 1 milliliter. Now we need to convert to kilograms per liter. So what we're gonna end up doing is we're gonna have to convert both of them separately, right? So if I was going to do grams to kilograms first, because we've already played with those, that we should be able to work, right? Then grams would have to be on the bottom and kilograms would have to be on top in order for it to cancel. So we know that 1,000 grams is 1 kilogram. Grams cancels out. We are now in kilograms per milligrams. Or milliliters, I mean. Now we need to get from milliliters to liters. Well, if we think about what milli is 1,000th, right? Basically going to tell us that for every 1 liter, there's 1,000 milliliters, right? And then the milliliters would cancel out. Now at this point, we're in kilograms per liter. So we'd multiply across, and what do you know? We end up with 1,000 over 1,000. Which is just 1. So it ends up being about the same because this unit is 1,000 of that, and this unit is 1,000 of that. So the thousands cancel. Don't mind me just punching the document camera accidentally. Stupid document camera. That one was intentional. Didn't let it get the last laugh. Huh? Let's do a couple more. The speed of light is approximately 300,000 kilometers per second. Convert this speed into meters per second. Well, this is actually going to be really easy, right? Because even if I set it up with 2 separate units, and yeah, I don't honestly care that it's a big number because big numbers are as easy to multiply as small numbers if we have a calculator handy, right? This isn't going to be as hard as the last one because we're going from kilometers per second to meters per second. They're both over seconds. So we don't have to worry about this unit. We just have to worry about that one. So all we need to do is convert from kilometers to meters. So kilo means 1,000. So for every 1 kilometer, there are 1,000 meters. Kilometers cancel. We're now in meters per second. And all we really have to do for multiplication is kind of tack those 3 zeros on this many zeros. 1, 2, 3, 4, 5 to start. 1, 2, 3 tacked on. Meters per second. I put commas between those. You write this many zeros, you start understanding why We're so used to putting commas every three numbers. So 300 million meters per second. That's insanely fast.
The speed of light was 4 seconds.
There's a speed of light in meters per second.
Meters per second.
So think of a meter stick, kind of close to a yardstick. Imagine 300 million of those getting covered in 1 second. Makes more sense why when you flip a light switch, the whole room lights up rather than gradually getting lit up. Don't really think about that, but yeah, it's emitting light, but it's emitting light fast. Big number. Let's do another. Sarah's textbook has a mass of 1.2 kilograms. We're converting that to grams. Well, that's boring. I don't like that problem. It's pretty similar to the first problem. That's why I'm unhappy with it. Feel like making it harder, but I don't think so. Let's just keep going. Well, kilograms to grams. Kilograms would have to be on the bottom so it can cancel. And remember, a kilo anything is 1,000 of the regular unit. So the kilograms cancels out, and we end up with 1,200 grams. Yay. Yay. I'm tired. Okay. So how do we feel about unit conversions? Are they a little less painful than last class? No, it was 5 days ago.
Yeah. It's painful that days.
Well, let's make it a little more painful.
No,
I have to make it a little more painful.
just say, oh, it was.
Oh, you're writing it? Okay. Yeah. There we go.
If I want to be there, I wanna do before. I wanna do food before I skip once, before I keep seeing the video.
Yeah.
Really. Way more different. Okay, thank you.
My Amazon package was delivered at 7 at night. What? Oh, okay. I ordered some meds for my mom on an auto shipment, and I guess one of those went through. Okay. So obviously, we're having a lot of fun with the metric system. We've never had this much fun in our lives. We are so excited to finally do a few on our own. I made them nice and easy, no word problem stuff happening. And all of the unit conversions are along the side. Except, you know, when I type it in properly. In fact, let's kill a few of these. Like I said, there's only a few of these units that you'll ever actually use. I can use a centigram. Kilometer, centimeter, millimeter, that seems right. Yeah. I'm actually going to change these around so they fit. A little better with the fraction idea. Don't know how that got past me. So those are the ones where you might actually find yourselves using them. Let's try to make this a little bit less painful to look at. There we go. That's kind of pretty, right? It's only 6 of them to work with. That's all you really need to worry about. Okay. So go ahead and take 5 minutes, see if you can work these out. If you can't, that's fine. We'll work with them together afterwards, because I imagine I'll probably end up doing all 3 of them anyway, right? So give them a shot and see how we do.
1 kilogram has 2 point something.
What was that, sorry?
1 kilogram.
Kilogram?
Yeah. Thousand.
It's 1,000 grams. Yeah. It's been about 5 minutes. How did everybody do? Wonderfully, terribly? Anybody online? Anybody online want to say something?
I need help on all of these because I'm not good with grams.
Okay, that's fair. All right. Time to look at them. These were what we probably should have gotten. So let's look at them real quick. Let's see, we had 250 grams to kilograms. We had 2.5 liters to milliliters. And we had 500 milligrams to grams. Okay. So converting from 250 grams to kilograms. We know we would need grams down here and kilograms up here in order to cancel the grams, right? So now you just fill in the numbers that work. 1 kilogram is 1,000 grams. So the grams would cancel. We're now in kilograms. You'd multiply across, we get 250 divided by 1,000 kilograms. And you can either reduce that to 1/4, or honestly, with unit conversions, I tend to recommend a decimal. Unless explicitly stated that you want a fraction. But if you divide these guys, you end up with 0.25 kilograms. And I didn't leave myself enough room here. So the next one, honestly, about the same amount of room. We have 2.5 liters and we're converting it to milliliters. So 2.5 L over 1. We're going to multiply that by a conversion rate. The liters would have to be down here and the milliliters up here for it to work. Now, milli is 1,000th, right? So there are 1,000 milliliters for every liter. So the liters would cancel out. You'd multiply straight across 2.5 times 1,000, 2,500, 2,500 milliliters. And then the last one, converting 500 milligrams to grams. We're going to write out 500 milligrams over 1 here. And we need a conversion factor. We're going to go from milligrams to grams. Similar to the last one, Whereas 1,000 milliliters per liter, it's gonna be 1,000 milligrams per gram. So 1/1,000. When you multiply across, we end up with 500 over 1,000 milligrams, or not milligrams anymore, grams, because the milligrams canceled out. Your division, and this is just half of that, so 0.5 grams. That makes sense? And just sort of,
kind of.
they kinda. Big fan of kinda. Yeah. How do we feel about unit conversion? Are we good with them? Do we want to see more? Do we want to do more? Do we want to move on? Nobody's gonna say they want to see more. Move on time? Move on time. Welcome to geometry. So geometry involves the study of various geometric figures, their properties, the relationship between them. Explores points, lines, angles, curves, surfaces, and solids. Now, in terms of geometry for this class, we're only going to be playing around with the general shapes. I don't think I'm going to have enough time to play around with lines or angles. Going to have a little bit of after geometry. We're going to have a little bit of tables and charts, and we're going to have a little bit of algebra, and that's going to be pretty much it. So of course, next week is the last week of class. So we're going to have fun with that. So, goal of geometry is to understand and analyze the characteristics and measurements of these objects. We will primarily deal with polygons. Those are shapes enclosed by line segments, such as rectangles or triangles. Understanding geometry and its related concepts, such as perimeter, area, mass, and volume, is crucial in various practical applications, ranging from construction and architecture to engineering and scientific fields. So, like I said earlier, we are going to be primarily working with perimeter and area for these ones. Perimeter refers to the total length of the boundary or outer edge of a two-dimensional figure. It's found by adding up the lengths of all the sides of the figure. So perimeter is measured in units of length. And as an example, to find the perimeter of a rectangle, you add the lengths of all its sides. Pretty basic. Area is the measure of the space enclosed within a two-dimensional shape. Measures the amount of surface covered by a shape, essentially. Area is calculated differently depending on the shape. Area of a rectangle is the easiest example because you multiply its length and width together. Area is typically expressed in square units, such as square centimeters or square meters, or square feet, or square miles, or whatever really you feel like. So of course, the first shape we're going to deal with is rectangles. And this is so very true. You know, that evil dude that does one good thing before they died. Anime characters are all sad. Oh, it's okay that he killed 1,000 people because he saved one last person in his last breath. Fiction's weird. They pull that all the time. So So a rectangle is a four-sided shape with opposite sides that are parallel and equal in length. All angles in a rectangle are right angles, which are 90 degrees. A square is a type of rectangle where all four sides are equal in length. We know what a rectangle looks like. We all have phones. We're all looking at screens right now. We're looking at a slide in the shape of a rectangle, talking about rectangles with a rectangle of a meme on the side of it. They're rectangles. So perimeter of a rectangle is found by adding the lengths of all of its sides. For a rectangle, opposite sides are equal in length. So because of that, there's a formula for it. The formula to calculate perimeter is 2L plus 2W, where L is the length and W is the width. Now, this isn't to say that you can't just add up all the sides. But since opposite sides are the same, you could just take one of them and double it. Take one of these, double it, take one of these, double it, add them together. That's where the formula comes from. Because it's better than saying L plus W plus W. There's two L's and there's two W's. So as an example, if you have a rectangle with a length of 6 units and a width of 4 units, you can find the perimeter by saying 2 times 6 plus 2 times 4 ends up adding up to 20, and you call it good. Pretty simple, right? We also have area. Area of a rectangle is a measure of the total surface enclosed within its boundaries. It is calculated by multiplying the length of the rectangle by its width. The formula is A equals LW, where L is the length and W is the width. Since you're multiplying 2 units together, the result is in square units. So the example here is if you have a rectangle where the length is 8 and the width is 5, 8 times 5 is 40 square units. If they were both in like feet, then it would be in square feet. If they were both in miles, it would be square miles, etc. Pretty simple, yeah?
Looks like.
Yeah, they're not bad. Hey, look, a bunch of problems. Let's see, I don't feel like I like having this many problems. I don't want to have that one in there. I don't want to have that one in there either. Okay, those are the ones we'll do. I changed the layout. That can be too small. No, cool, all right. Na, 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 na. Cool. Don't mind me just relayouting and rewriting stuff as I go, as usual. So. Rectangles. Rectangular garden measures 8 meters by 5 meters. What is the total distance needed to enclose the garden with a fence? Well, there's a rectangle. Isn't it beautiful? It's not to scale. Just remember, your drawing can be as ugly as you want to write it, and then just write not to scale somewhere, and technically you're okay. Probably not, but you know. Okay, so we need to enclose this area in a fence. And since this is a rectangle, we know that this length and this length are the same. This length and this length are the same, right? So for the perimeter formula, it's 2L plus 2W, because we don't really need to say 8 plus 5 plus 8 plus 5. We could just plug it into this and it'll spit out our perimeter, right? So personally, I'm going to plug it in like that. My usual way of plugging things into formulas is to replace the variable with a set of parentheses and whatever number I'm doing. Because that way, if I do it that way, any multiplication isn't gonna be broken, any weird stuff happening with any other things. It's gonna be safe, right? So at this point, we would just figure out what this is. So that's a 16 and a 10, we get 26. And everything's in meters, right? This is twice the length in meters plus something in meters. So our units are in meters. I would recommend having your units on there at all times.
How did you get the 16 and 10?
2 times 8 is, 2 times 5 is,
Oh, because when,
yep, we're just cleaning this up.
okay, let's say we have 26 meters.
Yep, 26 meters around. Okay. Let's do more. So this one actually starts off giving us a perimeter. So it says the perimeter is 36 meters. If the pool is 2 meters longer than wide, what are the dimensions of the pool? So this one actually has a fair little amount of algebra in it. So we know that the long side is 2 meters more than the short side. So what I would tend to do, I always tend to draw a picture. But on problems like this, you kind of have to reason your way through it. So what I usually like to do is first of all, I find what everything's in terms of. So is everything going to be in terms of the length? Is everything going to be in terms of the width? Well, this statement is comparing the length to the width, right? We're extending out the width to find our length. So that means we're kind of starting off with whatever the width is and then playing with it to find the length. So what I would do is I would just put a W here. We don't know what it is, but we know it's our width, right? And our L, which would be down here, our length, well, we have something we can call that. We can call that, well, it's 2 meters longer than the width. So we could say either 2 plus W or W plus 2. I would write it as W plus 2 because it makes you a little less dizzy. Now, let's see how quickly I can lose you. Let's have fun with this. So on a problem like this, what I usually do is I write out my formula. I might know it, no problem. That's perfectly fine. I might know the formula, no problem, but I'm actually going to be putting things into this because we know this part. We know that part is 36, but we don't know anything else, right? We know one of them in terms of the other. Well, a useful thing to know in algebra is that if you have one equation and you only have one variable, you can solve it. Because if I have 36 equals 2L plus 2W, what is that? I could give you a answer. I could tell you, oh, well, if the width was 1, we could figure out what the length was, no problem, right? But what if the width was 2? What if the width was 3? What if the width was 4, etc.? But if we have one variable, we can actually solve for that variable. So what I would do is kind of like when I substituted in here for knowing that my L was 8 and knowing that my W was 5. In this case, I know that my W is just a W, but what do I know about my L? It's a W plus 2. So when I do my substitution and plug something in for that L, it's not going to be as simple as an 8 like the last one. It's going to be this thing. That L we're going to put in terms of the width by putting that W plus 2 into it. Now this might look confusing, but all we've done is swap the P for the 36, which we know that the perimeter is 36. And we've swapped the L for the W plus 2 because we know that the length is W plus 2. So we've swapped those guys out and now we have this thing. Well, there's our algebra for the day, right? Don't worry, there's a bunch of them like this. Not really the best types of problems to cover if I haven't played around with a ton of algebra before, but you know.
What's P mean?
Perimeter.
Oh, okay.
So this is our equation we got to solve. Once we figure out what the W is, well, we'll be able to know what the L is, right? Because our L is whatever that is plus 2. So let's figure it out. Now, since I have this number outside of this set of parentheses and I can't clean up the inside at all, I'm going to have to use the distributive property right here. Distributive property, if you remember, is saying that, hey, this 2 outside is going to have to distribute to everything inside. It's going to have to multiply. Nothing's happening with that 36, but over here, I have to do 2 times W, and then 2 times that plus 2. And now we don't have a set of parentheses anymore. We do still have that plus 2W trailing down from our original formula. Now, I haven't covered like terms quite yet, I don't think, at least not to the extent I'd like. But the idea here is that I have 2 W's and another 2 W's. Got your message, it's okay. I have a total of 4 W's here, right? But this thing doesn't have a W on it, so it's not going to fit in with these guys. Now, our goal here is to get the W alone. We got to get that alone on one side. So what I'm going to try to do is we got to get rid of this 4, and we got to get rid of this 4. I can't get rid of this 4 yet because if I had, since it's multiplied onto the W, if I divided by W dot 4 here, I'd have to divide by 4 here, I'd have to divide by 4 here. Generally, I leave that term alone until it's the only term on this side. In this case, I'm going to subtract the 4 first. I get a 32. 32 is equal to the same 4W, and now I can deal with that 4. This 4 is in the way, it's multiplied onto the W, so to cancel a multiplied 4, we're going to divide a multiplied 4. There we go. So the 4's here cancel. There's going to be W. And then you say, okay, 32 divided by 4. You could grab a calculator. You could say how many times does 4 go into 32. No matter how you do it, you're going to end up with the same number regardless. So we get 8 equals W. Well, the question is, what's the length and what's the width? If I said 8 equals W, that wouldn't fly, right? I need to actually be able to say what it is. What's our width and what's our length? Well, we know what our width is now. We know that it's 8, and then our units is M, so meters. So if our width is 8, then what's our length? Well, we have to figure that out, right? If our L is W plus 2 still, well, now that we know what our W is, we can just plug it in and we get 10. And that's also in meters. So, as for answering the question, either box that guy up right there or say 10 meters. You could write it out as a sentence. Personally, I'm lazy. 10 meters by 8 meters. That's our shape. No. Do we have any questions on that problem? Because I know that covered a few concepts we haven't played with all that much yet. Questions? We're perfectly happy with this. This made great sense.
Yeah, really simple. Okay, so.
Gonna do more, we're gonna have fun with it, right?
Let's do more.
Yeah. So the next one. Oop, 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 oop. Sorry, I'm breaking something on my phone at the same moment. But the next one, number 3 says the area of a rectangle is 48 square units. Did I delete the problems with the simpler area problems? Yep, I sure did. Okay, well, I brought number 3 back from the dead. Kind of needed it. All right, so it says a rectangular rug measures 10 feet by 7 feet. Calculate the total area of the rug, indicating how much fabric is needed. Kind of a weird statement. I don't like that phrasing. Yeah. So we're looking for the total area of this rug. We know that the length is 10 feet. We know that the width is 7 feet. We don't necessarily need a drawing for every one of these problems, but it can come in handy to reason through what it is we're doing. And area, if you remember, is multiplying the length times the width. So this one's actually pretty quick. We have to find the area. We're going to just multiply the length times the width. Well, that's 70. Now, what the question was actually asking by talking about how much fabric is needed is kind of just wanting the units, right? As it is, we're dealing with feet and we're dealing with area. So what is the unit going to be? Well, if you have any questions about it, usually you're pretty safe to say that if you're dealing with an area, you're dealing with square feet. If it's not feet, it's inches, etc. But if you think about it, we have 10 feet multiplied by 7 feet. Think about what happened when I multiplied an x times an x. We ended up with an exponent, right? We got x squared. Well, that's what ends up happening here. We end up with feet times feet, This is feet squared or square feet. So the units, like with the unit conversion stuff, units canceled the same way that numbers do. They also multiply together the same way that regular numbers do. The units actually follow the same algebraic concepts that everything else does. Does that make sense?
Not using them, the last one.
Don't worry, because we're gonna do something kind of similar to the last one, but much harder.
And the other one?
It's gonna be pretty similar to number 2. Second here. Hmm. Okay. Look at the next one. So this one is talking about just the area of a rectangle and square unit. So we don't really have any units to speak of. We don't have feet, inches, whatever. It's just units. So it says the area is 48 square units, so A equals 48, with the length being twice the width. Find the dimensions of the rectangle. So similar to that earlier one, we're given the overall area, and we have to figure out what the length and width are. Now, this is telling us that the length is twice the width. So similar to that earlier one, where the length was the width plus 2, where it was 2 longer than the width, this one's twice the width. So if this is W, then in our case, the length is going to be twice that, 2W. Okay. So if my usual formula is A equals LW, length times width, and I know that the area is 48, well, I'm going to substitute in for these variables the same way I do here, but just like that earlier one, we don't have concrete numbers to put in there, but we have algebra to throw at it, right? So the length is something we're just going to call 2W. And that's going to multiply by the width, which is still just W. Now multiplying these is pretty basic. We have 2W times W. Well, what happens when I multiply an X times an X? We got an X squared, right? So if I multiply a W times a W, I get a W squared. 2W squared. So 2 didn't really get played with at all, but the W did. Now we got to figure out what the W is. Well, that's a shame, right? So we're going to divide off the 2. So we get 24 is equal to W squared. And remember, we had an application when we covered those with exponents and roots. We said that a root was the way to cancel the exponents, and vice versa. You can cancel a root with an exponent. That's what we're going to do here. Since we need to get the W on its own to get rid of that W squared, we're actually going to have to square root both sides. running out of room, but let me rewrite it right up here. Square root of 24, we haven't played with yet, but the square root of w squared is just w. Now, we could go to the trouble of doing the prime factor thing and breaking this down and all that, but we're dealing with a word problem. We're dealing with lengths of units. We're not gonna give them like a weird square root thing, right? Sometimes you do that with triangles, but if you're dealing with a word problem, you're generally not gonna leave it as the square root of 24. What I'd probably do is just find what the square root of 24 is in your calculator. My calculator just broke it down. Thanks, calculator. Probably just get a decimal. Now, if I look at this, how many digits would I need? Everything's above a 5. The first one I wouldn't have to round would be over here. Because if I rounded this to the nearest whatever, this would go up, this would go up, this, they would all go up. So I'm actually just going to round this to about 4.9. Because it's so insanely close to 4.9. I'm going to say 4.9 units. Now our length is going to be twice that, right? Length was twice the width. So the length is 2 times that 4.9, which is about 9.8. You can always verify that by just saying, yeah, that thing times 2, not 22, just 2. 9 point, oh my God, when is this thing ever going to round? Yeah, we're going to call it 9.8. So we have our width and we have our length. Do we love it? We love it. We love it so much, don't we? So number 5, a patio has a rectangular shape with the length 3 feet longer than its width. Well, that sounds a lot like number 2, doesn't it? If the area is 54 square feet, what are the dimensions of the patio? All right, same sort of shape I'm drawing. We have that the length is 3 longer than the width, and the area is 54 square feet. So I wrote it out this way. The length is 3 more than the width. I prefer W plus 3. I don't know about you, but it looks better to me. Doesn't matter, but you know, we don't know anything about the width, so we're just gonna put a W. And it gave us the area is 54 square feet. So we know that the width is in feet and the length is in feet. Okay. All right. So same sort of thing as the earlier problems. I write out my formula. Again, you might not need to write the formula. You might have it memorized by now. But even if you do, even if I do, I still write it down because then I can very easily see where I'm translating different pieces of it. Like the A is very clearly going to translate to that 54. I never get rid of these controls for Zoom. Drives me nuts. The L, we're going to change to this W plus 3. Remember how I said that, you remember how I said that I used AI to write this problem? Or write a lot of this? We can't work out this problem. At this level. I haven't covered enough for this problem. I can't. This is a no-go. This whole problem. Can't solve. Now, if you want to see why, it's because when I multiply this through, I end up with W squared plus 3W equals 54. And unfortunately, this is a quadratic function. This has its own way of solving it that we have not covered yet. In fact, it's a little bit further along. Yeah, there's no way I can solve this at this point. Thanks, AI. You suck. Yeah, so we can't actually solve this one. I apologize. Let's wrap that idea. Yeah. Very nice, very nice.
Yeah, his style, his views.
Let's do something similar. We can only do them with multiplication right here for now. Anything with addition is just gonna break. So let me make up something else real quick. Let's see.
Make it a hard one.
If I wanted to make it a hard one, I would just leave this as is.
A solvable one.
Hey, you remember when I was going over radicals and roots and what have you, and I showed you some formula that I said you would commit to memory someday?
Yeah.
Negative b plus or minus square root b squared minus 4ac all over 2a. That's how you solve that one.
That's light work.
Actually, there might be a nicer way of solving it. If I can find factors of 54 that add up to a 3. Well, of a negative 54. Try to assume. I don't know. Let's not play with that. Let's say that I had. Same idea. Same sort of setup. Same sort of setup. And my length was. Six times the width. Those things like skinny. Let's say that I need an area to give it. I want an area that gives me something reasonable. Say that our area is 96 square feet. And we were trying to solve this guy for the length and the width. So I was to do that. Same sort of setup. Same sort of replacement. The area is 96. The L we're swapping out for 6W. Width we're leaving the same. And this ends up very similar to the earlier problem where we would multiply the W on there. We end up with 6W squared. We have to get the W squared alone. So we're going to divide off to 6. 96 divided by 6 is 16. And then to find the width, we would have to square root both sides. Square root of 16 is 4. So we get that the width is 4. Now we need the length, which is 6 times the width, which is 24. So we have some shape that is 24 feet by 4 feet. Sorry about the destructive problem. But does this make sense to everyone? I have to fix that next time I teach this class. Good stuff. I'm kind of curious. Yep, there's that problem happening right there. I very well might have just made the weirdest swimming pool ever by that number right there, by what I just did.
Mhm.
But yeah. So here's the thing. I'm starting to feel like crap. I want a nap. I don't know why I'm feeling like crap. I think I have a cold now. I think I caught a cold in the last couple hours. I'm very upset about this. So I'm gonna call it good. For tonight, we're gonna just call it good at rectangles. Next time, we'll come back, we'll do some more examples on rectangles, then move on to types of triangles, circles. I don't know what else past that. Oh, Pythagorean theorem. Oh, I forgot about that. We'll have fun with that. We'll have a lot of fun with that.
Yeah, I took the post test again
Yeah.
today, and the radius and the what is that? The radius and what?
Radius, diameter.
Yeah, the radius and the diameter got me.
Well, you'll see it Thursday, guaranteed.
Hell yeah.
Hell to the yeah. All right, everyone. Have a wonderful evening. Thank you for showing up. Thank you for somebody coming in person. That's great. Huge fan of that. All right, and have a good night, everyone.
Okay, thank you. Have a good night.